trig. Hello to those who are near and those who are far. Shalom lakarov and shalom larachok.
What?
In Hebrew, shalom lakarov and shalom larachok. It's a very nice line from the Bible. And it fits now. Some of you are near, some of you are far. Anyway, today we're doing more trig graphs. Okay? We're not learning anything really new, but it is a little bit more complicated. Guys, your books. Okay? Right, so we're in page 99, exercise 14, and I'll do question A together, and then the rest you guys are going to do there and probably finish tomorrow. So we've got these graphs. Okay, we've got f of x, which is 2 cosine x. We've got minus cosine x in red. And now we are asked not to draw the graphs. They drew the graph for us, but we need to calculate certain things. So you still need to understand all the stuff that we learned about the graphs in the last couple of lessons. So they're asking us to find what OA and OB. Let's start with OA. Guys, and I'm asking those who are here. Okay, is this still working? Yeah? OA. What is OA going to be equal to? Okay. Looking at the graph, okay, so obviously to do with the black graph, 2 cosine x, what will OA be? Length. This is O. O. A. OA.
The amplitude.
It's the amplitude, which is 2. Okay, because we know that's the amplitude, right? Okay, we've got A sine x plus Q. Okay, if we have a general equation like that, the A is the amplitude, Q is the vertical shift. Okay, what is OB? The length of OB. 1. Okay, B is actually minus 1, but the length of OB is 1. Length is a certain size. Okay, cool. Moving on. Determine the length of CD. Okay, now that appears to be a little bit different. What? So how are we going to find the distance between these two peaks? The peaks and the trough.
Would it be minus whatever t is?
OC plus OD.
Yeah.
So not OC, but we can call that, let's say, M. Okay, so it's going to be M. So we want to find CD. So what we're going to do is find MC plus MD. So we made M is just some kind of point in the middle. In other words, this length plus that length, which is equal to MC is going to be 1 plus the amplitude here, which is 2. So it's 3. Okay? See, it's pretty easy, pretty straightforward, but it's a little bit different to what we did so far. We alright, guys? Please pause me if you're not sure. We're moving on to 3. Determine the length of EF. Now we want to find EF if we know that OE. Okay, OE is 315. What does it tell you that OE is 315? It tells you what the angle here is. What is the angle here? 315, exactly. So if I know that this is 315, how would I know this distance? What do I need to do?
315.
What do I do with that 315? I got to do something with that 315. Okay, if you need to move it. Okay, what is this? This is the y value, right? EF is basically the y value of this function. So how do I know what the y value when x is equal to 315? What do I have to do?
Put 315 in.
Exactly, I need to put the 315 into the function. Which function? The black or the red?
Black.
The black. So I'm going to put, 2 cosine, and yes, please put that in the calculator. 315.
So you just said that.
Oh, sorry, I didn't hear.
1.41.
And you times it by 2, yeah? 2 cosine. 1.41. That's probably 2 times square root 2. Okay, cool. Alright? Because this is, no, let's not get into special angles right now. It's not important. Moving on. The term, I'm going fast, guys, but please pause me. Okay, I will pause here for a second. Okay, right, so now we're at 4, and they're asking us which values of x between 0 and 360. Okay, I think 360 is going to be, where's 360 going to be? We all have yeah, it's all cosine. Okay, so 360 is going to be somewhere there. Okay, so when is f and g going to be equal to 0? Which values of x? Okay, here we need to just know our cosine. Okay, in this case cosine, because the graph we have is cosine. When does cosine equal 0? Okay, what value of what angle is it going to be equal to 0? So you need to remember it. I can see you don't exactly remember it. Okay, but the cosine is 0. I'll draw maybe the circle. Can I draw it here? Yeah. Okay. So if you remember, okay, this is why it's so important to remember that circle. Okay. So cosine x, okay, is going to be equal to the opposite or the adjacent divided by a hypotenuse. What is the adjacent? It's the x value. Okay, so it's going to be x divided by r. In other words, it's going to be 0 whenever the x is 0. When is that going to happen? For what angles? Over here and over there, right? That's when the x is going to be 0. So what angle is that? 90 and 270. Just adding 180, okay? So it's going to be a 90 and a 270, okay? Doesn't matter if I have a minus here or a times 2. Whenever that cosine is 0, then the whole thing will be 0. You can see they're crossing the x-intercept in the same places. So it's going to be a 90 and 270. That's the answer both for f and for g. Okay? If you're not sure about it, then I guess you can put it in the calculator. You can say, okay, cosine x equals 0. How do you do that? You do that x cosine minus 1, right? You do cosine minus 1, 0. Okay? X equal cosine minus 1, 0. Okay? But then you're only going to get one answer. That's why it's important to know, to be able to use that to know when is the next value of theta, which will give you 0. Okay? So it's 90 and 270. Let's quickly go on to part 3. Part 3, we've got f of x equal 2. Let's try and figure that out. When is f, that's the black one, becomes 2? When is the value of f equal 2? For what values of x? It's 0, 0, and 360. Okay? Okay, so you're starting, or you need to start getting intimately involved with these sine and cosine. You need to know that the cosine and the sine become the amplitude at 0 and 360. Okay, I'm just going to pause here for a second. Okay, so I skipped some of the questions where kind of repeated themselves, and now we're going to inequalities, which is, I don't think we've done it before. Okay, so here they're asking us which value of x, f of x, which is the black function, is below 0, smaller than 0.
All the values of this one.
From here to here, right?
Yeah, 90.
Okay, and you're right. Okay, I should have already written it before. We know that this is 90 and this is 270. So look, you're right. It's between. Okay, we need to write x larger than 90 and smaller than 270. Now, should I put an equal sign or not? No, because they said when f is actually smaller than 0. At 90 and 270, it's equal to 0. So, okay? The same way, when is g of x smaller or equal to 0? With the equal. So, which values of x? When is which value of g? It's the rate equation. With formula.
0 to 90.
Okay, so we've got two things. So it's going to be between 0 and 90.
270, 360.
Between 270 and 360. So we have the word, we'll put it in red, or. So we have two areas. Either between 0 and 90 or between 270 and 360. Okay? Must I write equal signs?
It says equal to 0 then.
Equal to 0 is still good. So at 0, okay, at 0 it's definitely below 0, so that's true. But even at 90, which is equal to 0, it's still good. And the same here. So it's including the zeros, the equals. Okay? Just pause here. I know, the last one. Two more. When is f larger or equal to g? In other words, which value of x, the black graph, is above the red graph, right? Because larger or equal means that it's above it. 0 to 90. I'm going to write it now in a slightly different way. Remember, we can also write it like this, in brackets. Okay? And between 270 to 360. Okay? So we can either write with x larger or equal, or we write with these brackets. Again, we have two regions. Okay, it's this region or that region. So we're going to put the word or. And must I have square or circle brackets as I do? Square, right? Because equal, that's still good, right? So this is definitely square because it's definitely larger than the red one. But even at 90, might not be larger than the red one, but they're equal to each other, so that's fine. So it's all square. We are square. Okay? And the last one, okay, G is larger than F. So when is the red above the green? There, black. 90 to 270. Let's write it again like this. 90 to 270. What kind of circle? Because we don't include the edges because it has to be really a larger.
What happened to right square brackets for that? You use them all.
Say again?
You right square brackets.
Yeah, you will lose probably 1 mark. That will be 2 mark answer.
So how do you tell?
One?
So how do you tell when it's circle?
Okay. Okay, I'll explain because so here I need to write for which area of G, each region of X, G is larger than F. Let's look at 90. Is the red above the black? No, they're the same, right? They must be the same. Okay, there was a question, how do I know if I have a circle or square? Okay, the circle means it doesn't include, it's not including 90. It's just larger than 90, right? This is the same as, this is equivalent, I don't even know if they can see it. This is the same as x larger than 90, smaller than 270. Okay? So now in this case, I want to find when G is above F, larger than F, not equal to it, just above it. When the x is 90, they're exactly the same. So G is not larger than F. Right? If I move a millimeter to the right, the red is already above the black. Okay? So here it's going to be circular, here. Okay? Cool. I'll pause here. Yeah, what I'm going to do now, we're going to go over 6 and 7. Or 6 and 8, sorry. I skipped 7. Okay, 7 is a bit similar to 6. We'll do it tomorrow, but 6 and 8 are a little bit different. Okay, we want to find the value of x, where f of x is increasing. Increasing means going up. Okay, so I'll just help you. Okay, or you tell me from which point to which point is it increasing? You see these letters. And when is the black graph increasing? From D on to 360 degree, right? So what is the angle at D?
180.
180. Okay, so it's going to be between 180 and all the way to 360 because we're just ending at 360. Okay, will I write equal here as well? No, because it's just 180. It's flat out. A millimeter after that, start increasing. The slope is the grade is positive. So I won't have the equal sign. Okay? I stood out of that. So, yeah? Sorry, I'm just going to pause here. Okay, chaps, I let the class go because the last part that I want to do here is a bit difficult. I explained that to them, and now I'll try and explain that to you. So in number 8, they're asking us, it's a bit tricky, so bear with me. They say, when will the equation, or the graph of the equation, y equal minus cosine x plus k, not cut the x-axis? Okay, now what is the minus cosine x? That's basically my g, my red graph. Okay, so I've got, this is minus cosine x without the k. Okay, without the k. Or if I want to say, I can add to it obviously 0. If I add 0 to something, obviously I'm not changing it. So this is for k equals 0. Okay? I'll write k equals 0. Okay? Now, what does it mean that I'm adding a k? Okay? I'm adding a positive k, if I'm adding a positive number, that's a vertical shift, what I call Q here. So if I'm adding plus 5, that means I pull the graph upward. Okay? If I'm minusing, if k is negative, if I, let's say, minus 2, then I'm pulling it downward. Now they're asking which values of k will make this original red graph plus a certain k number not touch the x-axis. Now, we either can pull it up a lot. If I pull it up 10 units, obviously it's not going to touch the axis. If I pull it down 10 units, it's also not going to touch the x-axis. So I need to look what is the minimum value of k that I need to push it up or down. And beyond that, above that or below that, then that will be our answer. So the minimum that can move that up, I'll use another color, okay, is if this is minus 1, if I push it up 1, if I push the whole graph up 1, I'm going to get a graph that looks like this. Okay. If I do that, you just extend this graph. This is at 360. If I push it up all the way here, it's 0. This, which was 1, will be 2. This, which was minus 1, will be 0. Then it will just touch the x-axis. Just touch it here. Anything above it, if I push it even a millimeter up, then it's not going to cross the x-axis. Okay? So what values of k this is? If I push it up 1, then that must be y equal minus cosine x plus 1. I pushed it up 1. Okay? In other words, in this case, k is equal 1. Here k was equal 0. Here k is equal 1. When k is equal 1, it's still touching the x-axis in these two spots. But if I've got k larger than 1, it's going to be pushed even a millimeter up or more, and then it's not going to touch the x-axis. So I've got half of my answer. Half of my answer, which values of k will make this graph not touch the x-axis? The answer is k larger 1. But it's just one part of the half of the answer. Because I can take my red graph and actually pull it down. Okay? I can pull it down, let's say, to here. Okay? I can pull it down 1 unit down. If this is minus 1, that will be minus 2. The one that was 1 here will be 0 there. And for this, the answer is, for this equation is y equal minus cosine x minus 1. I shifted it down 1. Now, does it touch the x-axis? Yes, it still does over here, 180. Okay? So that's not good enough. What is the k here? The k here is k equal minus 1. You see, it's minus 1. But if k is smaller than minus 1, that will shift it even a millimeter down or more. Okay? Then that's also, then the graph is not going to touch the x-axis. So the other part of the answer is k smaller than 1. Now, here I got to be a bit careful, and this is a common mistake people will do. Okay? Some people might write these answers. I mean, it's k smaller than 1, k larger than 1. Some people might write like this: k smaller than 1 and larger than 1. K smaller than 1. Sorry. K smaller than, sorry. So, it's not k smaller than 1, it's k smaller than minus 1, obviously. I need to shift it down. So, I can write k smaller than minus 1, and I might write k larger than 1. Some people will write that. Now, does that make sense? Can k be, at the same time, larger than 1, and at the same time, smaller than minus 1? Now, obviously not. Any number that is larger than 1 is obviously larger than minus 1. So, we cannot write that answer like this. What we're going to write is k is smaller than minus 1, or, back to our or, k is larger than 1. I know it's tough, guys, but just give me a WhatsApp if you're not sure what I just said now, and I'll try and take you through it. Okay? Enjoy. For the rest of the work for tomorrow, what I'd like to do is finish this exercise 14. Have a lovely day.